Okay, welcome to a small little review over the radicals and exponentials. This will be on your no calculator portion of the test. So I'm doing this while third block is with me, or second block is with me. So you may hear people talking, and that's okay. All right, so when we see something like this, where we have a 2 is a 2, but we have a square root of 192, 192 isn't a perfect square, so I'm going to throw it into a factor tree. So a factor tree is basically I look at it and I think, what goes into it? Well, I see the 2 at the end. I know it's even, so a 2 goes into it. So to the side, I'll go ahead and do my little division. 2 goes into 192. So does 2 go into 1? Nope. Does 2 go into 119? Yep. 9 times, right? Because 9 times 2 is 18. I know I subtract. 19 minus 18 is 1. I bring down the 2. 2 goes into 12 6 times. So now I'm going to bring that over. And I go 2 times 96. Now 2 is a prime number, so I'm going to circle it, and I'm done with the factor tree there. I move on to 96. 96 is even. I could choose to divide by 2, but I'm like, ooh, 3 goes into that. And 3 is really easy, right? If I divide 3 into 96, 3 goes into 9 3 times. 3 times 3 is 9. Nothing left over. I bring down the 6. 3 goes into 6 2 times, right? So this breaks down into 3 and 32. And so 3 is a prime number, so I stop there with the factor tree, and then I go to 32. And so 32, 2 goes into it, what, 16 times, right? Prime number. And really, 16 I see as a perfect square, but I'm going to keep breaking it down, right? 2 and 8, and then we're going to have to scooch it down a little bit more. 8 is 2 and 4. So a factor tree, we're going to go and go until we have all the prime numbers, and then we're going to throw them back into the problem. So when I look at the problem, I'm like, okay, there was a 2, and then there was a square root of 192. But instead of writing 192, I'm going to write it as, let's see, how many 2's do we have? We have 1, 2, 3, 4, 5, 6. So we've got 1, 2, 3, 4, 5, 6, and then we've got 1, 3. Okay? And so we've got the square root. Now the square root says you're allowed to come out as long as there's 2 of you. See how there's 2 2's right here? That means 1 2 comes out. So I already have the 2 standing out here waiting. These 2, another one gets to come out. When you pull it out, it gets multiplied by whoever's standing there. These 2 are sitting there, so just 1 gets to come out. I'll pull another one out. So bloop, those are gone. These 2 are sitting there, so we go ahead and pull out another one. And then darn it, the little 3 is just by itself. It has to stay in there, so that's square root of 3. So then we just go ahead and multiply, and we end up with 2 times 2 is 4, times 2 is 8, times 2 is 16. And then the square root of 3 is just the square root of 3. So 16 square root of 3 is the same thing as 2 square root of 192. It's just in more a simplified form. If you put those in the calculator and hit enter, you'll see that they're the same thing, but this is simplified form. Okay, the next one, we don't have any numbers. We're just dealing with variables and their exponents. And so with this tells me the rule. The rule is how many groups of 4 are there for this one and for this one. So let's kind of break it down. If I could go ahead and write x 24 times, right? And I'm not going to do that. But each 4, because the rule is the 4th root, each 4, 1, 2, 3, 4, bam, would mean 1 would come out. We're not going to do that with 24. We're going to do a shortcut that says, all right, if the rule is every group of 4 can come out, let's see how many groups of 4 we have. How many groups of 4 do we have in 24? That's right, 6. 4 goes into 24 evenly 6 times. That means x to the 6 comes out. How many groups of 4 do we have in 7? We just have 1. So if you think about it, y times y times y times y times y times y times y, you can see there's one group of 4, so that's that group. So that's the y that got to come out. And then what's left over? There are 3 y's left over. Y times y is written as y to the third. So that's why, well, the y, the fourth root, has y to the third left over, because gosh darn it, if there's just one more y, another one could have come out. So this is our answer here. I'm going to double check that we are, I'm not sure what I just did. Okay, we are going, and who knows what I just did. All right, so let's go ahead and let's do the next one. So this is just multiplication. See, there's not, some people are like, oh, they pretend like they see a plus here, plus there. There's no plus there. We are not going to make this harder than it is. So all we see is we've got a 5 times -6, which is -30. And we've got a root 3 times a root 7. Root 3 times root 7 is the same thing as square root of 3 times 7. These two things are equivalent. And of course, 3 times 7 is 21. So this is root 21. So when we're asked to simplify this, we get that. Okay, now this one, there is a plus in here. And this square right here means that we need to write it twice. This means we have square root of x plus 4 times square root of x plus 4. We're going to go ahead and distribute square root of x times square root of x. Well, let's do that on the side. Square root of x times square root of x. We can say, well, that's the same thing as square root of x times x, which is square root of x squared. The square root and the square cancel each other out, which is x, right? So square root of x times square root of x is just plain old x. Square root of x times 4 is 4 root x. Then we distribute the 4. 4 times root x is 4 root x. Second block, could you just bring it down just a little bit? I'm almost done. Thank you. And then 4 times 4 is 16. We're almost done. We're going to go ahead and add these two together. And we end up with x, and then we have 4 root x plus 4 root x, so that's 8 root x plus 16, and we are done. This is our answer. Okay, so this one is another, hey, how many groups of 4 do we have? So we're going to have to be really careful because really this is like 2 separate problems. It's the same thing. We could write it as 4th root of 32 times 4th root of x to the 5th. All right, let's do the easier one first. This 4th root of x to the 5th, it's saying how many groups of 4 do we have in 5? We have 1, right? And how many left over? 1. So we're going to have this. This is going to be the answer for that part. This, we don't do how many groups of 4 do we have in 32. That grouping only applies to exponents. It does not apply to coefficients. We have to do this the long way, like with the factor tree. So let's think about 32. Let's make a factor tree. Let's break it down. Well, we got 2 and 16. That's a prime number. 2 and 8, prime number. 2 and 4, prime number. Whoop. And 2 and 2. All right, so we had to do the factor tree. And we'll throw them under. How many 2's do we have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Who gets to come out? Well, there's a group of 4 2's, so 1 2 gets to come out. Oh, that 2 is left back behind. All right, let's put these two things together. So when we're looking at this, now I separated it to try to make it easier for you to understand. But now that we can, understand what we're doing, basically when we look at this, so let's just bring this down a little bit. All right, so we have 4th root of 32 x to the 5th, right? Is that what it was? Okay. We already know that with x to the 5th, an x got to come out, right? And an x was left behind. And for the 4th root of 32, we've got that. So the 2 got to come out, and a 2 was left behind. So this is our final answer right here. And of course, as you're watching me do these, there's a couple different ways you could approach this. Just as long as we're getting the same answer, I'm good. All right, let's see if there are any more. Okay, so now we're going into where we have a fractional exponent. When we have a fractional exponent, we've got to be really careful about how we go about it. like I taught in class, we're going to tackle the root first. So in a fractional exponent, if we see a number in the denominator, that is our root. This says square root. So that's the first thing we're going to do. We're going to take 1/4 and we're going to raise it to the 1/2, right? So we're going to take care of this 2 first. That's the same thing as saying square root of 1/4. That's the same thing as saying square root of 1 over square root of 4. I'm really breaking this down. If you don't need to break it down this much, you could do it faster, go for it. Square root of 1 is 1, square root of 4 is 2. All right, we're like, okay, we did this. We're done with that part. We got a 1/2. So now we're going to take that 1/2, and we've got the -5, okay? So there's a couple different ways you can think about this. You can think about the negative as just flipping the 1/2 to be 2 over 1. But you don't have to. You can also think about it by saying, okay, that's the same thing as 1 to the -5 over 2 to the -5. That's one of our properties of exponents. And if you're looking at that and saying, I don't understand, that doesn't make sense, this is just go back to that first video where I explained the properties of exponents. This is just something we have to memorize. It's a rule. And so when I look at 1 to the -5, I'm like, oh, negative, that means I have to put it down here. When I see 2 to the -5, I'm like, oops, a negative exponent means wherever we are in the fraction, we've got to flip ourselves. So 2 to the -5 in the denominator becomes 2 to the 5 in the numerator. All right, let's go. We're almost done. 2 to the 5th is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 1 to the 5th, right? 1 times 1 times 1 times 1, it's just 1. So we end up with 32. Now, once again, I did a lot of work, and that's not necessary, all right? I mean, you can do all this work and come up with 32, or you could have done a lot of different shortcuts. You could have done some in your head, so don't feel like you have to follow my steps exactly. Once again, these are all no calculator parts of the test, and that's it. So there's more on the no calculator part, but those were the ones that had to do with radicals and roots. I'm sorry, radicals and exponentials, not exponential functions, but exponents. I'm sorry, trying to video this while my class is in session, so it's hard for me to concentrate. So these are the no calculator ones that have to do with radicals and with exponents. There we go. All right, thanks for joining me.